live cells are neat. It's interesting, but you have to understand that live cell has a DNA. The DNA is dangerous. When you put it into your body, it's going to turn into something. So if you're going after your tendon and that DNA is meant to be like a heart tissue, well, it's going to grow in that area. So you got to be careful. Now you're in a tumor formation. So that's
Welcome back, everybody, to another exciting show, the About That Water podcast, where we help the sandwich generation build strong financial habits so that they can talk about money, spend money, and enjoy their money with confidence. And I'm actually talking about you. So today, I have somebody who has pioneered the sports chiropractor industry, is a veteran of the U.S. Navy, and has been doing athletic for so many different years and has so much information to share with you all about stem cell research. Welcome to the show, Dr. Tommy.
Hey, thank you very much, man. We are exciting and gonna go into some weird things. Let's go into it.
So the weird thing is like, we always hear this thing about stem cell research and stem cell this, and we always hear about the needle that you got to get. First off, what is a stem cell? So we can start off there.
Yeah, good question. So stem cell, it's a group of cells. These cells are meant to do something, right? It's meant to start a process of growth. It's supposed to do like stimulate tissues to do its job. We always think about our cells have to do this replication of, destroying and rebuilding, destroying. Well, we need a type of cell that signals and start that whole process. And that's what stem cells are. Stem cells are that type. Now, there's different kind of stem cells. There's the big one. There's groups of them. They're like a totipotent, pluripotent, multipotent, unipotent. So all these, refer to the ability to do its job in a larger span. So the big ones are called totipotents, when they can do a whole cascade of things that can tell a hair, a follicle. We consider almost like a embryonic tissue. You think about a cell starting off at a zygote and work its way. So we look at that type. Then we look at the next step down, and we look at smaller, eventually down to a point where it's unipotent, where it has one job to do and turn it into that particular cell or that tissue. So when you hear about stem cell, it's just basically a starting point. So we in our body, we as adults, we have things called adult stem cells. And we need to stimulate those to do its unipotent or its potential to do its one process. So then what we're trying to do is we're trying to get some signal, something that turns on our existing tissue to start off that process. And then we look at things of other stem cells they call it pluripotent, or another name is a mesenchymal stem cell. Those are the cells that you want. Those are the cells that are going to differentiate into the target tissue, supposedly. But then when you start thinking about it, how does it do that? Well, it's going to be difficult because they have its own set of chromosomes, DNA, gene codes and stuff like that. And it's not going to really match to your cells, right? So then you have to think the next step, which is a signal. It has a signal to tell the actual tissue that you have damage with, turn on, do your job. And that's what stem cell is all about. It's not really the stem cell. It's what it secretes out, what they call the EV, extracellular vesicles. So I hope I didn't complicate things too much. It's a very complicating and unique world, because a lot of people really don't know what this whole world's about, but they just know the stem cell is a cool thing to help regenerate.
Yeah, and I thank you for geeking out about it just a little bit, because as we get older, for us in the sandwich generation, we trying to do our best for our parents, and we want them to live as long as they need to. The parents, yes, there's a whole thing about lifestyle that actually comes into play, but with specific stem cells, how can that actually help reverse some of the aging of the cartilage, and the benefits of stem cells?
So let's start off with the simple, when you think about aging in cells, in our age process, in our longevity, we have to go all the way down to the molecular level, right? The cellular level. We have to find out why are cells not reproducing. We always want a ratio, which is basically one cell destroys, then we replace it with one cell. So there's a 1-to-1 ratio, always trying to replace what we break down. It just makes us healthy. So then we have, our skin, our hair, everything gets just nicely grown and it's healthy, right? So when we age, we lose that signal to have that information to go down there to regenerate, to get that 1-to-1 ratio. So then as you age or you get injured, you'll start getting maybe like one cell destroyed, then 2 cells destroyed. Then you don't have that, the recycle of that 1-to-1 ratio. Now it's like 2 cells destroyed, 1 cell gets rebuilt. And then you need more time. That's why it takes us longer as an older person to recover from injuries, because it takes that longer process. So when you get down to the molecular level, then you have to think about, what do we need to do? Why are these cells not doing that movement, that type of like replication? Then you have to go down to that simple little guy down there at the end of the chromosomes that we all hear about, is telomeres. Telomeres are those secret type of like locking mechanisms that when we do these replications from RNA to DNA to do what they call mitosis, cell divide, and make these daughter cells and make these other tissue, well, we only have so many of those things. Now, in order for us to be safe, because these codes, these things called ATCG, it has this orientation to make, a code of a
DNA.
hair follicle or something like that. So when they start decreasing and you start going through replication, the telomeres get chewed down a little bit, because you don't want this code to all of a sudden start mismatching, and all of a sudden you start getting that world of tumor formation. So it needs some kind of safety mechanism before it starts losing the ability to be properly coded. So the telomeres at a certain point will stop this ability to replicate. So when it stops, it goes into like a zombie state, and it's like what they call senescence. So it just sits there dormant. It's waiting for something to happen, and that something needs to increase those telomeres back to its normal length. Now, in our body, we have this enzyme, but again, as we get older, the signal decreases. And this enzyme is called telomerase. Telomerase is that enzyme. Now, what's interesting is that we need to engage that enzyme in our body, or we need to get it from another source. And that source comes from, again, stem cells. Stem cell has that enzyme, that information and signal. So once you get in your body, there goes your telomeres growing back to normal length. Now it's ready. It's ready for that information. Here comes the next wave, the signals to tell it's that particular cell to do its job. And that signal comes in the form of like proteins, cytokines, enzymes, information that tells the cell to do its job. So it's like a 1-2 punch. The first one, increase telomeres by telomerase. The second punch is the information, the signal to say, now do your job. So once you get that formulation down, now apply to a human being. Now we're going into the longevity. Now we get that cell to be healthier. Now we're living longer, active. Because that's my thing. I'm in that age group where I'm thinking about retiring. So I'm thinking like, right, at 75, am I able to go, Europe and travel and be able to walk, or am I going to be, knee pain, cartilage pain? So that's why I'm very, very dear to my heart, because to be selfish, I'm thinking about me. So
right. Hey, get to. Yeah.
Yeah, it floats out that way. So I know that once we start advancing in this world of like regenerative medicine, stem cell therapy, it's going to be a very easy application for anybody to use. And that's where my thought process is. My thought process is that we have this world that's, it's injectable. You have to go to a clinic and a doctor, right? So it's going to go in its mutated phase into the future, where now you're going to start seeing it home application. You're rubbing on your skin. It's going to saturate through your skin, and then you're going to have those messages to those tissues to do its job. And that's where I see the future. And that's why it's real fantastic to talk about this stuff.
Yeah, we have a whole segment talking about the futures, but we're gonna get to that a little later, because right now we gotta deal with the right now.
Yeah.
And the thing about it is that, because you've been in sports realm for a while now, and seeing so many athletes from different races, different ages coming through, how do you actually extract the cells to actually know, like, hey, this is your cell? Do you actually gotta withdraw blood? Like, how is that taken care of?
So going back to that generation of stem cell therapy and the thought process. So as we continue on with this world of regenerative medicine, stem cell, it keeps evolving. It keeps on moving in its educational, the mechanical, and the knowledge of what really goes on. So in the past, they used to think that these cells, these mesenchymal stem cells, what they call differentiate, they go into your body as a live cell, meaning that they have a nucleus of DNA, and they would somehow turn into your existing tissue. And it, and generically speaking, it does that sort of pattern. But then when you take the next step down, you say, all right, what is it really doing? Does it really have the same code as the existing tissue code? No, it doesn't. So now it's about signaling. So when you look at the signal, now you look at that the information in the form again, cytokine, proteins, enzymes, and then you get it to the target tissue, and now it says the signal is bright, and then I know what to do with it. So when you take that information right there, that basic knowledge of that stuff, and then now you take it to an athlete or, a weekend warrior or somebody that, just needs to regenerate, have a little arthritis or some kind of pain. Now you're saying, how do I get that signal to your body? Do you have that signal? Yeah, you have that signal, but depending on your age, it can be very weak. So let's say there's a thing called PRP where you can draw your own blood. And then, you take in the centrifuge and you re-inject your damaged tissue area with the growth factors to help, heal the tissue. There's a good principle there, but the problem is the signal is as strong as your age. So it's like taking your own signal, shaking it up, getting a pure signal and shooting it back, but it's not bright. You want that bright, strong signal, and that's why you're hearing the donor site, the signal site from the umbilical cord of like a C-section delivery. And on there is called a Morton's jelly. And on there it has the mesenchymal stem cells. And that has the information that's very strong, bright. And that tells, anything around it to grow, to do its job because it's such a stronger type of signal.
Okay.
So now the neat thing is that you're starting to hear about plants that do the same thing as these signaling molecules from this tissue. So that's where the evolution is going to move to. It's going to move into all about signaling. That's why you hear things like exosomes, peptides. Well, that's all signaling information. It just tells you it's do something.
Okay. So I'm glad that you're talking about plants and also how you actually get it from human to human. I guess you could say extraction to implementation, because, we always hear about that the doctor's always trying to take the placenta of the birth. What do they use it for? And also, what are the controversies about that? Because some people just feel as though I don't want to donate that to science, or I didn't sign this off to be studied for science. So I guess you could say, what are the controversy things that you've heard about it in your practice?
Okay, so that's a great point right there. So on that side of it, on the medical side about the question asking the patient during delivery about that, the consent to take your tissue for research. Yeah, there's a lot of points to that. I'm more so of taking the tissue for the reason of the mesenchymal stem cells or the gelatinous material outside. When you're outside of the tissue, I mean, let's go for the umbilical cord. The umbilical cord is the connection between the fetus, the baby, and the mother, right? And it delivers all the nutrients through there. Well, outside is what we're trying to achieve. That mesenchymal stem cell, the gelatinous material called Wharton's jelly, that has the highest concentration, and it's not pretty much compromised by any type of like pathogen that's delivered from the mother to the baby. So that's really important. But when you think about the problems that we're having in the industry, it's not really regulated by the FDA. The FDA just kind of regulates the lab and not so much the clinical side of it. Because the clinical side of it is a broad stroke saying that from the FDA that this is experimental or research. That's why you have to sign more consent forms and probably a report that says that you're in this research and you're allowed to do this type of therapy. Other than that, it's not regulated. But then going to the donor side, we're starting to run out of these donors, right? Donors are basically volunteers from a C-section delivery say, would you like to give this tissue? And then you're starting to see less and less because you have to vet these people. They have to be pretty much drug-free. They have to have no pathogens, meaning no diseases, STDs and all that stuff. And there's a whole battery of tests, just like any type of examination you go through. There's a questionnaire, blood work, serology, all that stuff. And then when they clear, then we take their tissue. In exchange, they would get a discount for their banking of their cord if they want to do that for their child. So it's like a win-win in that world. But we're starting to lose those donors. They're starting to slow down and the supply is not there. So where the unethical side comes in is that you're going to start hearing all these labs pop up. These labs saying, hey, it's a lot cheaper. It's a lot easier. And then you think well, how is it cheaper? Well, this is where the FDA is starting to come down on these guys because it's not real tissue. It's either from maybe not really from the umbilical cord portion, the what they call the Wharton's jelly or the placenta, that gelatinous material, but it's coming from other tissue, like maybe vaginal tissue. Sometimes there's cases you hear about coming from bovine or animal or some pig. So you're starting to hear that come out. Now, on our end, as a clinician, we don't really see and know what's going on because we don't have that vetting process of a lab and trying to analyze what we're getting from the actual lab. So that's where the confusion is. So that's why it's very important to find out exactly who is your source, who is that, and there should be a process. Every clinic should have a type of form that you can follow, and what's it called, traceability forms. You can follow this form all the way back to the donor, and the donor will have its questions, the blood work, and all that stuff. So there's a big confusion out there about where to get it, how to do it, how's it match, and most important thing, going back to one more thing about a risk factor about these live cells that people like promote. Live cells are neat. It's interesting, but you have to understand that live cell has a DNA. The DNA is dangerous. When you put it into your body, it's going to turn into something. So if you're going after your tendon and that DNA is meant to be like a heart tissue, well, it's going to grow in that area. So you got to be careful. Now you're in a tumor formation. So that's a caution.
That makes sense. All right. So I'm going to dive into some of these questions that came in from a few listeners. So I have one. So this person's a runner, and they asked a good question. That's coming from Lindsay, and she asked about as far as what are the benefits of stem cell ointment has outside of pain and also ligament health, if any.
Okay. So as a runner, runners are basically a repetitive type of exercise. You're going over and over, same action, same movement, and same stress. When runners, interesting thing about runners is that they go look at miles per week. They want to put it in 30, 40 miles, and that's a lot of miles on their body. So if you don't have right biomechanics, you're going to have, compromising tissue, and then you're going to, break down tissue. And the tough thing about runners is that they want to continue on running when the tissue is breaking down. The most important thing about exercising is the recovery. You've got the compression component of it to break down the tissue. And then the secondary is the recovery. So then you're always coming back to 100%. So when you're in the running world, you're thinking about just thinking miles, and then you're pounding, and you're kind of going into that world of overtraining. You're trying to destroy tissue more so than rebuilding. So when you look at that side of it, you have to either, slow down, rest more, or speed up the healing. Speed up the healing is that side of that topical stem cell, right? So topical application, you want to quickly regenerate. You want to quickly, get that back to normal. The neat thing with topical is that, invasively speaking, right now, it's all about injections, right? You go through the skin, you inject that tissue that's compromised, and then you get it delivered that way. Well, the tough thing with needles is that you get that injury site from the needle. So then you got your own injury, and then the second one is that needle injury. So then you have to recover from that. That's why they say stem cell therapy, you need downtime like 1, 2, 3 weeks, and then doing nothing, and then you get back at it. Well, when you look at active people, they don't want that. They want to get going. So topical, with the transdermal component that can pull those information signals down through the skin into that target tissue, it gets to that tissue to start its process for its signaling. The neat thing about that is no downtime. You can continue on going. So as a runner, this is fantastic. It's almost like you want to think the 3 stages, right? You got the prehab world, then you got the injury, and the post, right? The rehab, right? So you want to look at much as possible at the very beginning. You want to prevent injury so you can continue on. And that's another use of this.
Okay. And she continued. She had some good questions here. One of them, the other one is about testing. Was this actually tested on people? Was it everybody, or was it just white men doing the original testing? Reason being is because vitamin D deficiency, as an example, was tested, but mostly on fair skinned people. And so, as darker skin, it just kind of looked like we always had a deficiency. So it's just out of curiosity, how was that tested?
So we had a random 80 patients. So we had our first test, and I didn't put that category of race and ethnicity in there. So just going back, I know we had everybody in that thing. I mean, it was just, there was athletes, there was weekend warriors, and then there's different females, males, and their races. So there's a mixture in there. But we just went after low back pain, and we went after pain as far as before and after. We had a 51% reduction of pain with RheeGen. But as far as that specific question, that's a great one. I haven't really looked into it, but I definitely know that vitamin D with, with darker skin, people think that you don't need to be in the sun. Well, you still need to be in the sun. That's the tough thing. So yeah. So it's interesting about that. I think there's a big case about that too, about
Mhm.
a study about, African Americans that don't go in the sun because, I don't know, maybe, I don't know what the reason is, but their higher chances of vitamin D deficiency is greater because of that fact.
Right. So I got a question from Crystal because she has some kids that are athletic, and she was wondering, how do you start them young? Like, how soon can you start them on the stem cell?
When it comes to kids, you don't need the stem cells. They before puberty, they've got so much signaling. They've got so much information. That's why they're growing, But once they hit puberty, that's where everything slows down a lot. That's where you start declining as far as that signaling ability or those kind of information that gets you going to get taller, bigger, stronger. So it's tougher. So as far as kids, I wouldn't do any of this regenerative stem cell world until they hit puberty.
Well, they actually in college. I mean, kids.
Oh, okay. When I hear kids, I'm thinking
Oh,
like
right, right.
4-year-olds. Like, no, if they're in college now, you look at, so if they're athletic and they're doing
Mhm.
sports and they get injured and they want to get back on the field, yeah, absolutely, they can go into it as long as they hit puberty and there's always going to be some type of like roadblock in their recovery. Like, it doesn't seem like it's getting better. I'm getting worse. Well, then the tissue or the signal is not getting that kind of information. So you got to get it going.
Got it. So I have Andre, who is also an athletic coach, usually doing flag football for women. And he says, well, he asked the question of, how long has stem cells been used for athletes?
Wow. So I say in the last 5 years, it's very pronounced. But see, think about what it's had. Regenerative medicine in some form started when I was, this is back in 19. So I heard of this stuff back in the 1990s, but it's called prolotherapy. What you're trying to do is just get something in your body to do something, right? That's all you're trying to do, right? If it's in form of like cells or signals or information, something has to do. So back then they used to call it prolotherapy. Prolotherapy is when they used to inject sugar water in your body, and because your body reacts to it, it thinks it's like an antigen, so it makes like these antibodies, and then all of a sudden here comes everything to rebuild that kind of tissue that's damaged. So then all of a sudden moved into the PRP world, and now it's stem cell, but came from your own body's fat tissue or bone marrow. And now we're getting it from a donor site that's coming from the umbilical cord or placenta, that gelatinous material, mesenchymal stem cell. Now it's going to evolve to plants. Now we're starting to look at not so much the cells, it's about the signal. So when you look at the signal, now just find the same signal, and then you're going to start hearing about plants that have that same information that you can get to your body. So it's been around a long time in the sense of regenerative medicine, but stem cell therapy it's still in its infancy, right? It's still starting off, still a baby right now.
And he follows up with this question because you actually answered a lot of his other questions.
Okay.
But with this one here, which is, what is the cost of using stem cells versus injections?
Okay. That's a big cost. So when you look at needles, there's cost with everything. That's the provider, the doctor, the clinic, the facility, right? And then that right there is a lot of money. And then, it's inconvenient for you to get out there and of course the downtime. So you hear stem cell injections between like $5,000 to $15,000. You may hear cheaper versions of it, but you got to then question, well, why is it cheaper than other places? Because you're looking at maybe it's not the right tissue, or they're kind of making some shortcuts, because it's a lot of process. And then once you get it, it has its, expenses with that. Now, when you go to the topical world, you eliminate the doctor, you eliminate the facility. Now you're at home. So that is, if you look at the retail price of that, that topical does the same type of information or signal as the injection, that's $1,000. Now, here's where it's going to be interesting about the future. It's going to move into the plant world. Once it goes in the plant world, now you're looking at a cost less than $100. So that's what I'm excited about. That's where we're moving towards.
Yeah. So, I mean, since we at the futures now, talk about the future recovery for athletes. So, you know, because it's going to be accessible, and do you find that plant stem cells is actually faster than human stem cells when it comes to regenerative?
It's going to be safer. It's faster. Here's a problem when you look at human type of like a donor side versus plants, right? So we're not really going after the plant stem cell. We're looking at the actual like the information that these plants have, in this extract. So if you look at human tissue, we want the signals from the human tissue, the stem cells there. Just like the plant has its own extract, which is a similar signal. So when you think about those two signals, you want to find out, all right, do I want to take the risk of taking this human tissue and then taking it in our body? And then let's say it has some DNA or something that's from the human tissue. It may turn into something, right? So you have a risk factor. Now you look at the signal. Okay, let's just look at the signal and say, all right, the signal is there. I have that, and it's going to be, it's going to have its kind of strength with the signal. Now, if you can find the plant that has similar type of information and that signal strength, now it's a 1-to-1 ratio. Now the bottom line is that what's safer, cost, and deliverability. So that's how it's exciting right now. So as far as a potency, human tissue has this potency, but plants are evolving in the sense of educating and discovering, wow, that information is strong, it's very potent, and it has similar ability as the human side.
Yeah. Wow. Okay. So for you, I know you said this is a cheat code for yourself because, I mean, you're doing the research. Why not experiment on yourself, right? It's almost given like almost a villain theme, like in every Marvel film. It's like, you know what? I'm a doctor. I'm going to inject myself, like Lizard Man from Spider-Man. Like he was like, I'm going to just inject myself to have regenerative attributes of a lizard. Where do you see this going? Besides the plants, do you think this can actually go out of hand where people just start growing extra stuff just because?
When you look at the human side of things, you got to be careful because that's why the FDA really regulates about cloning. Cloning is where you may have problems. You remember Dolly the sheep that they cloned years ago?
Mm-hmm.
And the problem with that is that they've discovered that when you clone, like an existing, like a chromosome DNA and stuff like that, and you clone it into a fetus or a baby and it develops into adult, well, because of that half-life that you've taken it, let's say that particular whole genes set are aged at 1 through 100, but then when you obtain it halfway into it, now you're not at the 100 mark, at the 50 mark. That's why that one had a lot of complications with it. With that, it's a lot of weird and interesting things that are doing, not here in the United States per se, right? But in other countries that are really experimenting about that kind of world. And then, hey, who knows where the future is at? So that's why you don't want so much the DNA component, the live cells. You want the signal. You want your own tissue to do its own job. So you have that bicep that should be your bicep, not like a bicep that has a heart muscle in there. You got to be careful what you're putting into your body. So that's why it's really important to understand about signals and not live cells. Now, live cells have the ability to do that tumor formation.
That makes sense because there was a movie called The Island that was talking about the duplication, but it was mostly celebrities because they're the only ones that could afford it. So pretty much they were cloning themselves so that if they broke an arm, they can just go down and take the clone's arm and then reattach to themselves because it's cell-to-cell replacement. I just hope it doesn't get that far.
No, can you imagine? I think, was that part of the movie where those clones had a personality just like them, and all of a sudden, so that's, here's a funny thing with people, right? We're always trying to experiment, and then some of these things are not governed. So there are people in some basement right now doing some type of, petri dish, making their own tissue, probably doing something interesting, and that's where the danger comes, because when it gets out of hand and they lose control, well, now it's out. So I don't want to say this, but it could be like COVID 2.0, right? So we got to be careful.
Yes, yes, yes. Um, Now, one thing, because I noticed that in your book, you're talking about your knee pain and how you're recovering from that. How's your knee, by the way, nowadays?
But that was Jeff's knee. So
Jeff's knee. Okay,
yeah.
I'm sorry. Yeah.
So that book is, so the reason why I wrote that book is there were people asking, questions over and over about that same type of topic. What is stem cells? What does it do? Why is it going this way? What? So after, a couple months of this, I've got to write a book. The book will explain everything as far as like different kinds of stem cells, what they do, and why it's dangerous right now and where the future is moving towards. But because of the science side of it, it was complicating as well. There's a lot of information, a lot of medical terminology. I needed another side of it to kind of, summarize what that whole thing's all about. And that's why Jeff helped me walk along with the layman's term to explain things in that format. So you had the science side of it, and then you got Jeff talking about the summary of what the whole science side is. You can follow his journey from having knee pain, discovering stem cells, learning about the procedure now, and then where the future is moving towards.
Yeah, because I think that is a great, powerful story to kind of start about where you are today and how to improve your life. Because we also hear about a lot of people trying to do things in their own hands, which is fasting. While you're going through this treatment, is fasting helpful? Do you need to change your lifestyle with
No, you don't
this?
have to change your lifestyle. You can just
Oh,
be whatever you're doing, you continue on. Our body doesn't like to have a lot of taxation. Remember when you tried to do two things at once and it was so complicating? So, like anything else, like when I work on my athletes in some kind of rehab, I give them one exercise and I don't complicate things. When you give them a set of exercises, they'll come back and their exercises are like, what are you doing? Because, well, they start combining all four exercises into one, and then it just mix match. So same thing when it comes to, regenerative medicine and changing your diet. Stick with one thing, change that or add that and keep everything the same. And then if it needs to be changed, it'll change. But I don't change anything. Just do the regenerative medicine, continue on your lifestyle, and keep going.
like it. Is there anything you want to leave the audience with before we dive into the final four questions?
No, no, no. I think this is a great topic, and I love that you have questions prior to the show, so then you can kind of like throw them at me from your listeners.
Oh, yeah, it's my job to do my research.
I love it.
All right, ready for the final four? All righty. So, question one: what does wealth mean to you?
Wealth means to me, I think the biggest thing with me is wealth, money or richness. I think I want to be rich with time. Time is what I want to have. I want to get my time back because in this world, it's about developing, consumption, learning, you know, all kinds of factors that we know that we have to do that thing called work and research on. I want to get that back. So I think when it comes to wealth is wealth of like me, like having time, to get rich with time, to get wealthy with time. So that's what I'm looking forward to is the end goal of just like enjoying my life, And I'm not a big money guy, so I love, to enjoy whatever I have at my time instead of being, drawn into deadlines and times. So I think that's a big thing with me is when you say wealth, I'm thinking like time, time.
I like that. Number two: what was your worst money mistake?
Oh, shoot. I'm gonna tell you right now. Here's something weird about me. So I've got a lot of quirky things. I don't know if it's disability. I don't know what it's called, but I've got some things going on that, you know, anybody with ADHD and all kinds of ADD. Yeah, you know how we are, right? The worst thing about me is that I think I can do anything. It's that like that. Yeah, I'll do that. I'm like that dog that sees a squirrel, right? Squirrel, squirrel. I'm looking around. So I think I could do everything. And that's probably the tough thing is that, focusing, just staying stop looking at other things, just focus on your things. I think that's the big big thing. I apologize. What was the question again? I got me thinking about squirrels. You're going to see them drifting away again. What was that question again?
It was what was your worst money mistake?
Okay, so because of that, these adventures, right? Thinking like I can start this business, I can start. So I've got probably like 5 big projects right now.
Jeez.
I wouldn't say they're mistakes. It's just that I just wish I would have done one completed that instead of like starting this, starting. But they're all still in progress. We're still going forward. So I wouldn't say the worst mistake. It's just that I just wish I took my time and finish the first one to go to the second one. But like anything else, you just got to go with your personality and keep going.
Totally understand. I got stories too. Number 3, is there a book that inspired your journey or changed your perspective?
Books I read are kind of like journals and just, I hate to say, but books are not in my repertoire when I do what I do. It's like mostly like there's articles and there's a lot of topic. So the one thing that if I think about my journey in this world, it's that self-confidence. I don't know why, but I just feel like, because of my personality, I feel like I can accomplish anything. And then because of my longing to be curious about things, I research things. I research and I dig deep. So it could be about stem cells. It could be about like your biological activation in your cells and see how to like get the best out of it. It could be about the weirdest things, right? It could be like home improvement stuff. So as far as a book, I can't pinpoint one book.
Gotcha. Yeah, that's interesting. So was there like I'm trying to think of like what got you into like just studying and really excited about the world in general, I guess, like from a young age or?
For me, I'll be honest with you, man. This is the weirdest thing. Like, you hear people talk about stuff and you're always like, are they, is it true what they're saying? Well, you question, because wait, are you telling me this, that? And then you start diving deep and then you have to go down that rabbit hole. And then you don't want to, you listen to the generic side of the videos and what people are interpreting what that is. Then you actually go to the source and you read the actual article or the study or the research. And then from there, you question him and you keep going. You say, all right, where are they obtaining their sourcing, right? Where's this information? And then that's how you start obtaining information. So I think because of that and just trying to see, is there a reason why they're answering that question that way based on this information? And then you read about it, goes, oh, I see what they're saying, but maybe they're interpreting it wrong. So that's what I did. It's just basically my own curiosity and just trying to figure things out on my own and believe in other people.
Yeah, I like that. I think the world would be better if we took that same perspective.
Oh, 100%. Nowadays, you see things, you're here like, what? What? No, there's always like, you always want, how it goes. There's always two sides of the story, but you only hear one side. Goes, I don't believe that. And sure enough, there's the other side. And goes, you can relate to all these things. So I'm like, I get it.
I love it. Number 4. What is your favorite dish to make?
God, you're going to hate me. Watch this. I don't cook. I think the best thing I made last night was top ramen.
Hey, you ate it. You put some extra sauces on it or you just kind of...
You know it. Look, I try to kill... Look, this is what I learned. You put enough garlic in that thing, you put enough hot sauce in that thing, so I went to military. So the military food, it neutralizes taste buds. And you have to carry the Tabasco sauce. You got to do what you can. Hey, I remember in the military, you go out. So I was a Navy aircraft carrier, flew in the jets, all that stuff. And when you're out and about and you run out of fresh food, you have to go to the powder stuff. You get these powdered eggs. So the water that they use is, like recycled from salt water. They distill it and all that stuff, and then you drink it. Well, because of that, I guess they would purify it with chlorine and other chemicals. So you're taking a lot of toxins in, but you got to drink what you got to drink. So I remember because of the chlorine and the powdered eggs, there are, 2 type of chemicals, I guess.
Right.
The eggs would turn green. So you would look at the eggs and it's green. It's green eggs. So that's why you need Tabasco sauce. You put that, green, red. It kind of turns back to yellow, I think. I don't know, but you have to hide everything you can. That's why you see a lot of military guys understand. Goes, yeah, you gotta carry your own packs. You gotta carry your own condiments there.
Like that. Man, okay. This might have to turn to another show. I might have to just have another show just talk about food because this is great. Well,
I'm a
Doctor
great. I'm a great. I'm a great. What's that utensil? That cooking apparatus? Microwave? Oh, I'm great at that right there.
Yeah, I'm trying to get away from the microwave, so I'm using like the induction ovens, what they call them things. You know what I'm talking about.
Yeah.
That thing.
The only problem with that is that it takes too long. I'm like I'll eat a bean of, what do you call it? Like, in fact, yesterday was terrible. I got the minute rice, you put it in the microwave. And then I got that, Vans Cam beanie weenies.
Yeah.
Here I am. I'm opening it up. I dump it on the rice because the rice is so hot that the rice is cooking the beans. And I'm sitting there and I think like, I'm too old for this stuff. What's wrong with me? But it tastes so good. It's like, wow, this is so good. But then realizing, I'm gonna pay for this later. So that's why I have to go exercise really hard. Just what I did that during that meal.
I'm sure you got some extra stem cells that day.
Oh yeah.
Well, Dr. Rhee, it's been amazing having you onto the show. Man, it's I guess the very last question of the show, which is, where could people find out more about you?
You can go on my website, RheeGen, RheeGen.com, and then you can see everything about topical stem cell. But then there's an info button. You can hit that and then say hi to me or ask me a question. And then, of course, the book is on Amazon, The Future of Regenerative Medicine. And just put my last name in there and you'll find that and you'll learn about stem cells.
Awesome. Well, thank you so much for coming through. The person that's listening to this, I just want to wish you the best in everything that you do. And remember that you have what it takes. You have the resources here. And if you need a recovery, hey, go on, look into stem cell research. Go on, check out Dr. Tommy if you in Florida, I believe, with the Tampa Bay area, right?
Yes.
See, I remember research. So if you're in the Tampa Bay area, go on and check them out. Say hi, tell them you listen to the show and you want to learn more about it. Cool. All right. Well, thank you, everybody. Y'all be safe. Be out. Peace.